everybody. Hey, welcome to today's lesson. We're talking about box and whisker plots. But nowadays, most people just call them box plots. Just box plots. They're called box and whiskers originally because you have a box and you have whiskers coming off the edge. But really, it just sounded too kiddish, so they started calling them box plots because that makes them sound more scientific. What is a box plot or a box and whisker plot? A box and whisker plot is a plot over a number line that breaks numbers into 4 equal groups that creates 5 boundary markers. The markers have the following names. And so what I'm talking about is, so pretend that we have this big chunk of data here. And if we cut it into 4 parts, 1, 2, 3, 4 parts, then we end up with 1 boundary, 2 boundary, 3 boundary, 4 boundary, 5 boundary. That gives us our 4 parts. So that's what they're talking about here. The way we label these things, the first 2, and I'm not going to go in order here, I'm going to go with just what's simplest. They call the lower extreme, but we all have probably heard the word the minimum. The minimum is your lowest value. And that's always easy to find because you say, what's my smallest number? Then they talk about the maximum, or upper extreme. Maximum sounds easier. The maximum is just the biggest number. And then we've all learned at some point, we've learned something called the median. The median is the middle. The median is the middle of your data. When your numbers are in order, you just go and you go to the middle. And we'll show you what I'm talking about in a little bit, but the median means the middle of your data. It's not the average, it's the middle. You take your data, take it, lay it all out in order, and start at the 2 ends, and work your way to the middle, and that's what the median is. It's also known as quartile 2, and then we have the lower quartile and the upper quartile. And they sound really confusing. We call them Q1 and Q3, or the lower quartile and the upper quartile. They sound weird, but this is really what happens. I have my data. I look at it and I say, okay, there's going to be my minimum. And on the top here is going to be my maximum. And then I find the middle because I have it all in order, and that puts my median, also known as quartile 2. That's a 2, promise you. And then to find the lower quartile, all I do is I find the middle of the lower half. And that's my Q1. Or my lower quartile, LQ. Or to find the upper one, I can go take the upper half and go 1, 1, dot, 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 all the way to the middle, and that becomes my Q3, which is my upper quartile. And what this does is it basically takes all my data and breaks it into 4 parts. Each part is 25% of the data, meaning that each part has the same amount of numbers in it. They may not have the same value, but if there are 10 numbers here, then there has to be 10 numbers here, 10 numbers here, 10 numbers here. If there are 7 numbers here, then there have to be 7 numbers here, 7 numbers here, 7 numbers here. It breaks it up into 4 equal parts. So if you look at this graph, I would say, okay, what is my minimum on this graph? My minimum looks like it's over the -5. So I would say my minimum is -5. If I was to look for my upper extreme or maximum, I'd come to my graph and say, okay, it looks like the upper extreme is right here. It's over the 9, so my maximum looks like a 9. If I was looking for my lower quartile, or my Q1, I'd say, okay, my lower quartile is right here, and that's above the -1, so that would be -1. And if I was looking for my upper quartile, that's over here, or Q3, and that's above, it doesn't look like it's exactly on a point. So then we're going to just guesstimate. We're kind of guessing and estimating. And we're going to go by halves because that seems best. I mean, some people are like, well, that's 6.4 or 6. No, just, this is like 6.5, so we're going to call it 6.5. Or 6.5 also is a correct answer. And then finally the median's right here. That's the middle of the data, and that's a 1. So that's the idea. Let's look at another one and see if you can try and do it yourself. All right, so here is the box plot. I want you to go ahead and look at it and label it and fill this all in. Okay, I'm assuming you paused and did this. If I was doing this, I'd say, okay, the minimum is the smallest, and so my smallest is over here. Here's my minimum. And I'm not sure, it looks like it's not, I'm going to go ahead and just call it -7. You could argue that it's -6. I would accept -6.5, but we can also call this -7. And then I'm going to look for my maximum because those are my 2 easiest things to find. My maximum is my biggest piece of data. My biggest piece of data is here at 7. So that's cool. And then my median is this one in the middle. This is -1. And then my lower quartile, or Q1, that's -3. And my upper quartile, it's right in that middle again. I'm not sure what that is, so I'm just going to call that 4.5. Now, one of the things that people say, again, remember in the last slide I said that each one of these has 25% of the data. So I know that each one of these has an equal amount of numbers in it, right? But that means if I have 4 numbers here, I have 4 numbers here, and 4 numbers here, and 4 numbers here, but it doesn't tell me how far apart those numbers are spread. For instance, here, if it's between -7 and -3, then my numbers spread out 4 numbers by 4. I could have 100 numbers there, but they're spread between -7 and -3, so you could say the range of them is about 4. But look at this. This is also 25% of my data. If there are 10 numbers here, then there are 10 numbers here, but these numbers are only spread out between -3 and -1, so the range of that is 2. So even though there's the same amount of numbers, how they spread out changes the way the box and whisker plot looks. So here, between my medium and my upper quartile, this quartile still has 25% of the data, but it's between -1 and 4.5. So that looks like if you took the range, I think the large number subtract the smaller one, you get 5.5. So my range is between 5.5. And then finally, this last one is between 4.5 and 7. So we would take the difference, right? 7 minus 4.5, and we get 2.5. And so the range of this one is 2.5. Now there might be 100 numbers here, there might be 5 numbers here, there might be 2 numbers here, but their range, how far apart they're spread, is 2.5. All right, so hopefully you can do the questions below. Go ahead and knock those out. And we'll see you, or let's try this one really quick. Go ahead and pause and try it. Okay, I'm going to assume you did this. This should go a little bit easier. Again, I start with my minimum. That's here. Looks like -8. And then I'll go up to my maximum. That looks pretty easy. That's 10. Then my median, that's in the middle. That's 0. And then my quartile 1, or lower quartile, -5. And then my upper quartile, or Q3, is 2. And again, each one of these has 25% of my data. Meaning if I had 100 numbers, each one would have 25 numbers in it. But this one's just more spread out. All right, you should be able to do the questions below now, and we'll see you for the next video.